Hello everyone, it's a real pleasure to welcome you to the second day of the CAS Virtual Showcase 2021. This session we're going to be looking at cross-curricular computing, and I'm really excited to welcome Helen Cotton and Sally Jordan. My name's Sarah Zaman. I'm the Outreach Manager for the North East and Yorkshire, and I'm your host for today's session. We're also joined by John Chippendall, who's also an Outreach Manager for CAS in the North East. John will be the moderator today, and he'll be moderating the question window for me. So just before we start, I've got a couple of things to share. In terms of housekeeping during the session, please use the question window on the right-hand side of your screen to ask questions or share comments. The top of the window's got an orange rectangle which can be expanded or collapsed. John will be making a note of questions throughout the session, and these will be answered if time allows at the end. We may have time for a quick question after both of the presentations. Please tweet, retweet, post, share and comment on today's event using the hashtag CASVirtual21. Make sure you get your capital letters in there. And as a reminder, all attendees are in listen-only mode. Okay, so first, we're going to introduce our first guest, Sally Jordan. Sally's a primary school teacher at Acacia's Community Primary School in Manchester. She's been a CAS community leader since 2014. I've known her all that time as well, and is an SLE for computing and IT, an MIE expert, Barefoot ambassador, Code Club leader, and a CEOP ambassador. Absolutely brilliant. Lots of things there, Sally. Okay, I'll just hand over to you. Thanks.
That's great. Thanks, Sarah. So really nice to have lots of people joining us today. I'm just going to share my screen. So this is my session today. There we go. Is that okay, Sarah? I presume?
Yes. Yeah, can see it.
Okay, so today we're just going to be talking about Scratch Maths, and in particular a sort of cross-curricular art project that I've done with my Year 5 pupils. Hopefully today this is what we're going to cover, just a bit of an introduction to Scratch Maths, where the resources are, where the sort of curriculum materials are, and a brief outline. And we're going to just look at some Scratch projects. So Sarah has the links for those, so hopefully you'll be able to access those and have a little go yourself while I'm sort of demonstrating as well. I just thought it was useful to talk through the, it was an Islamic art project in terms of sort of the teaching sequence that I've done, sort of more of just a guide to a medium-term plan really. I've got a few examples of some of the pupils' work, and then finally at the end, obviously there's lots of resources out there for linking computing with art. So to start with, we've got the website, which is Scratch Maths. Obviously, if you just search it, it's actually a project, a joint project that was created by the UCL knowledge base, and there's a short video there if you wanted to look at the background. It basically is a links between obviously programming and maths. It has been funded by the EEF, which is the Educational Endowment Fund, and designed, as I said, by the UCL Knowledge Lab in London. I think it's been designed really to support teachers with both their subject knowledge in terms of mathematics, but also linking that to programming and the primary computing curriculum. A really useful document which is here is called the Scratch Curriculum Overview. And what I really like about Scratch Maths is it comes with a huge amount of materials, and for example here it's designed to cover sort of Year 5 and Year 6 maths, but as you'll see to start with, there are some mathematical concepts that come in earlier year groups, such as, for example, symmetry and repeating patterns. As you can see, modules 1, 2 and 3 cover the Year 5, it's community Year 5, and then there's 3 more that cover Year 6. Today I'm really just going to be looking at the first module, which looks at sort of patterns, and then also an element of the module 2 in terms of beetle geometry, which looks at creating simple 2D shapes. What's really great about Scratch Maths is the huge amount of teacher support materials and example scripts. For example, there's teacher materials, there's lesson plans, as you can see, and there's support videos. It really is a step-by-step approach to if you're completely new to Scratch. It gives you examples of screenshots. It also gives you the starter projects as well, which we're going to be looking at today. There are presentation slides for every single lesson, and there are also things like additional challenges, vocabulary sheets all made, and also really useful reference posters. For example, this one here I think just highlights the numbers of colours that you can use in Scratch. Here's their sort of pedagogical approach, which they call the 5 E's. And I think if you've experienced, you know, the barefoot materials and the CAS materials, and more recently the PRIM approach to programming, there's lots of overlap in terms of exploration, tinkering, prediction. So very much sort of reinforcing those sort of key pedagogical approaches that you'll have come across through CAS and barefoot materials. So just to start with, this is where I started with the tile stamp. And I think Sarah does have the Scratch files which she can share with you. Yeah, so for example, yeah, the first one I think is tile stamp. Here we've got a very simple the scripts that are already there. Obviously it's labeled to say please don't move, because you can demonstrate to the children as you move, it goes back. Why is it going back? You can start to explore sort of X and Y coordinates and explain, well, it's going to erase all as well. So for example, if I'm just clicking on my stamp and stamp, so very much the children can explore, they can make certain patterns, they make a symmetrical pattern, and it just sort of gives them a very quick introduction to, again, we can click back, we can start again. So it's a really nice way just to introduce that sort of click and stamp. And I think in previous years, I'll have taught sort of year 2, and we will have done some very simple things in terms of repeating patterns. So it could be used very much earlier on in a year group. Quite nice also, right click to show the children how to save the image. Again, later on when the children will have created some art, saving their images, inserting it into a presentation or saving it, again, is good for evidencing the work, and also incorporating and putting into other documents as well. So again, that's tile stamp. That's probably where I'd start. There are other steps. I think if we go back to sort of the overview, you can see here that there is very much a structure for the step-by-step approach. For example, what's really great as well, there's also have some unplugged activities which you can explore as and when, and there is that sort of progression. Obviously today I'm just going to take you through the projects a bit more quickly, so now we'll just move on to that introducing repetition, but also changing costumes, and therefore sort of alternating patterns. This file at the top is called tile repeat. So as I said, here it again introduces to different costumes, and here now we can then decide, well, if we're going to move and turn, and this time stamp. So again, it's experimenting with different turns. You're then moving into sort of more mathematical. If I reset, you might, if you have a number of degrees we've got here, we might say, well, actually, how many times have I had to click before it makes a circle? So we'll count out. Okay, we can then choose the next costume. We can then add in and create different patterns. They can experiment. What would happen if I turn different degrees? And then this links quite nicely into the sort of mathematical support away from the computer where you can, we've got here, so we're looking at numbers of degrees in a whole term. So for example here, we've got 8 times 45 would be 360. We've got 4 times 90. So again, you're talking about whole term, which again sometimes is quite difficult for children to visualize in terms of that 360 degrees. So we've got there, again, we can take that away from the computer, and then the children can then use that to experiment, and then what other patterns can they create. For example, if you went back to the script, we've got, oh, well, I wonder if I could, if I wanted to do 6, how many degrees would I have to turn to make 360? Obviously, if you, we can, and if I click, I have to count that, 1, 2, 3, 4, 5, 6. And again, then you would start to introduce that repetition. How can I introduce repeat? How many times have I repeated that? And then we can clear. Would that make the same thing? Next costume. Again, so they're exploring that mathematical. 6 times 60 is 360, which is a whole term. So again, they're exploring those sort of different patterns. It moves on again then to look at rows patterns, and rows patterns is sort of the next sort of step in terms of lots of different costumes, but also the not just move and turn, but actually move forwards, stamp, move backwards and turn. So slightly more complicated in terms of the instructional, the program we're using. So for example, here we've got a hexagonal, switch to hexagon. I'm going to move and turn. So again, okay, I've not put my stamp, so I'd have to click that. And again, going back to those, again, those numbers of degrees, if I've got 8, let's count, we've got 1, 2, 3, 4, 5, 8. Would that work with a repeat of 8 times 45? Let's test that. So we've got those sort of patterns. Then the children can experiment by changing the costume. Might be this one. And then they can start to build up different patterns. Let's see if I've got another one. So that's the sort of rows patterns. And the progression from that would be then for them to obviously create their own block, which they might call a rose, for example. Again, you could show, we can duplicate those scripts, and they can build up that those patterns and then save them. The final thing, which one of the things I moved on to actually after that was within beetle geometry. We looked at actually 2D shapes, again, because this follows on in terms of that mathematical knowledge of factor pairs for 360. So here we've explored those sort of 8 times 45. When here we've done 4. Before we've done 4 patterns by using stamp. This time, how many repeats would we need and how many degrees would we need to make a total turn? So the children would work away from the computer to have a think, well, what exactly would I need to, my factor pairs for all these, for 360, for all these different numbers of sides. Also looking at patterns of numbers. So for example, if 4 times 90 is 360, can we actually work out, using our mathematical and multiplication knowledge, what 8 times would be? If we've got 10 times 36, what would 20 times be? So again, applying those mathematical concepts to actual the programming of the shapes. So to go back to our final one, which is actually drawing polygons. Again, this is a script which is provided by Scratch Maths. Questions could be, how would you share that with your pupils? Often we could just share it as a URL, but if you do have a teacher account on Scratch, what I've done with the classes is create a studio so the children can access that in a shared place. They can then access the file, they can remix it, and then it becomes their own. So actually their work is saved on their login. So it's often a better way instead of them just sharing a project. So again, we've got a script here that we don't change. I suggest probably before moving into drawing, as it does in Scratch Maths, there's an introduction to actually using the pen. If it doesn't appear here, it's an additional block on your Scratch. It's as an extension, it doesn't appear straight away when you log in or you're using Scratch. So you would have to add it in. So there is a lesson which does introduce drawing, pen size, all those different concepts of actually using the pen before you move into maybe drawing shapes. But again, we've got hopefully that knowledge about those factor pairs again. We've got 6. So how many times we've got a repeat of 6? We've got to turn 6 times 60. Is that 360? Would that make a whole turn? We've again got our move. We can then talk about what, I'll click on that, and there I'll just show that it actually shows the beetle. So what sort of shape is that? How do we know? How many sides has it got? What sort of angles? The actual degree of turn, I think, is an external degree of turn. And I think then you can experiment with, did we say what 8 was? It was 8 times 45. They'd have obviously the factor pairs calculations with them. I'll just do that. So as we said, if we did repeat 16, what would we have to change that to make it 360? Let's have a check. Would that make a 16-sided shape? Sometimes what we did do then, instead of actually erasing everything all, you could then, what we have done is change pen color. So they could change the pen color to a different color. Does that work? Pen color to that one, and then repeat. There we go. So it's red. Then from the actual drawing of all those different 2D shapes, and this links us to one of the resources that I talk about as well, which is the Crystal Flowers by Barefoot, and that talks about nested loops or loops within a loop. So here you've got your repeat or your loop here, count controlled loop, and then you can place it within another loop. So what we're going to get now is a 16-sided. Let's just check the degrees. I might just change that to, let's try a hexagon, a repeated hexagon first. So we've got a 6 that we know times 60 is 360. Then we've got it within a 6 times 60. Let's erase all. And then this would then create a hexagon, but then repeat it and turn it again. So what the children can then do, they've experimented with maybe building up patterns, making it bigger, making it smaller. Can you, instead of, could we change the color? Could we make it a different pattern? Let me try the color again. Set pen color. Then they can build up patterns of different colors. And the other thing, because what we initially with before we started the project, we would have done research on those Islamic patterns, those colours, those sorts of patterns that they were inspired by, that then they would try and recreate within Scratch. So, for example, if they'd instead of putting a background, they might just paint the background by using the fill tool. They might think, well, actually, I like those colours. I'm going to create my background, which is like this, and then they can build up their art depending on what they've looked at in terms of their research.
It looks really good, Sally. Thank you.
And finally, really, this is just what we've done in terms of a sequence of, as I said, we've got a really high sort of Muslim population. So the Year 5 topic, which is sort of early Islamic civilization, fits really well within that. We start with exploring Islamic art, patterns, colour. Obviously, that links in terms of searching for images, copyright-free images, online safety, etc. So that's a really nice way to start. We used Scratch Maths, looking at the stamp, the move, the repeat, the turn, the rose patterns, and then also incorporating that beetle geometry, drawing sort of 2D shapes and progressing then to nested loops. That resulted with obviously sort of towards that the culmination of that was a creation of presentation with their own designs and inspirations, obviously feeding back to class. And then when we were able to obviously showcase that to parents in terms of family learning, etc. Just quickly at the end, just a few examples. Obviously they've found their art, they've created different patterns. Here a child has obviously looked at these colours. They've looked at ways of changing the language by the looks of it there as well, but looking at rose patterns, changing the colours. And here looking at, again, sort of repeated shapes. And what's really nice is that obviously within Scratch you can right click, you can comment. So again, the children can evidence their learning or what they're actually there, so they're explaining their program as well. So it was a really nice project for them to work on, and so they enjoyed it, and you know, we can see how it linked really well to sort of maths, computing and art. In terms of other resources, there's for those of you that know about the NCC, obviously the unit for repetition in shapes, it actually is very similar in terms of obviously the algorithms and the 4 times 90, etc. that you'll use, but it uses logo. The Year 5 unit, which is vector drawing, I think that looks at, I think it uses Google Draw, but to draw different shapes, etc. And I've obviously referenced the latest sort of crystal flowers, which are using the PRIM approach to programming, which looks very much at those creating 2D shapes and then those loops within loops. Finally, there's the Teach London Computing, which links computing, science and art, which I think also links to things like mosaics and pixel art, which are really nice things to look at as well. And finally, Always Computing, who's great on Twitter, again another CAS leader from Bradford, who's done a nice blog which looks at some of the ideas from Scratch, in particular using, you know, repeating patterns, some of and random spots, and you incorporate that into art, which again links back to Scratch Maths.
Oh, thanks, Sally. It looks amazing, but we're gonna have to stop you. It looks absolutely amazing. Everybody gets the slides afterwards. That's just, I love it. I love Scratch Maths. I've used it as well years ago, haven't I? And I need to probably look back into it. But you've done some amazing stuff. Oh, so thanks for sharing. Thank you. Okay, so just onto our next guest. We've got Helen Cotton. Helen is a subject matter expert for the NCC in South and East Yorkshire, Humberside and parts of North Yorkshire, lots of areas there. She's one of the primary leads for the York Computing Hub, and she also enjoys leading 3 CAS communities in and around her network areas. She's also an associate with Amazing ICT. So over to you, Helen. Let's see what you've got to show us.
Thanks, Sarah. Thank you. Okay, so I'm just going to show my slides then. Am I sharing now, Sarah?
Not at the moment.
Okay, I'll try that one again. Do I need to change presenter?
I'll just try now.
Yeah, that's great. Okay, so I think you should be able to see my slides shortly. Is that okay?
Yeah, we can see them. You can, if you want to press present, it's up to you. But that's fine, we can see them.
Yeah.
Brilliant.
Lovely. Okay. Oh gosh, I think my computer's doing something funny. Okay, right. So we're going to be looking at computing and music for this cross-curricular link. So I'm going to be focusing mostly on Pro Music Lab. And as a musician, I really, really like the link that you can make with computing and music. So is that flashing at all, Sarah? My screen's going funny.
No, it's not flashing. It's fine for us.
Oh, good. My screen's going black and then coming back on again. Right. So what I'm going to do is I'm going to go through these slides as best as I can, but yeah, my computer's not happy with what I'm doing. Okay, right. So I was really going to just show you very, very quickly what the NCCE unit looks like when we're looking at Chrome Music Lab. So it's a year 2 unit. It's called Making Music. If you haven't come across it before, I'm very, very quickly going to go through it, but then I want to show you some other ideas for looking at Chrome Music Lab, and particularly we're going to be looking at the Kandinsky element of Chrome Music Lab. So this NCCE unit is a year 2 one. You get the introduction given to you. It is all about making music, so sometimes it doesn't feel like a computing lesson, but it is. And I think when we go through this, you'll start to see the links that are happening with computing more and more. So I think what you're going to find is that there's going to be a nice link to using repetition. And of course, when we're programming, we need to think about teaching that concept of repetition to help the children create their programming, be nice and creative, and not have to repeat the same blocks of code all the time again and again. So of course, we're going to be looking at repetition in that way, but also sequencing. So as we are sequencing our notes or our rhythms or our melodies, that's going to make a nice link in with computing as well. Now, this year 2 unit starts by looking at Holst, and the children are asked to listen to the 2 pieces of music. So it's Mars and Venus, and then it's very much a, just listening and then sharing what their thoughts were as they listen to the music. So the children will have to do lots of speaking and listening and think about what they noticed about them. There's then a nice unplugged activity here where we get to think about really the timbre of the different instruments, being able to describe the instrument's sound or that music sound and how it makes you feel. Has it gone loud? Has it gone quiet? What sort of instruments allow that quiet sound to come through, the sort of smooth and peaceful sound with Venus, and then with the Mars music, what is it that makes it feel so strong and yet so warlike? So the children are able to then get their little bits of their words and then sort them into the 2 piles. So the whole time they're really being introduced to lots of different musical terms as well, like timbre, but at the same time they're also sorting and finding patterns as well. So make some nice links to computational thinking. So as we move on, lesson 2, we're looking at rhythms and patterns. And again, we're thinking about computational thinking, that the patterns comes into play a lot. We want the children to be able to notice patterns. So looking at music is a great way to get them to focus on what pattern is and what it might look like. But I suppose here with music, also what it sounds like. So the children might use colour to start off with, and then they're going to match that pattern with an instrument. And as they go on to Chrome Music Lab itself, and I'll show you these in just a moment, there's lots of different elements to Chrome Music Lab. So the children can have a look at using different instruments to experiment with rhythms and patterns. So this is just one of them that you can use. Actually, this is one of the slides from the NCCE, from their unit. So you can see it's really, really clearly laid out, arrows and displayed everywhere just to show you what everything does on the screen. And if we're looking for different instruments, we know that that's at the bottom, but we also want to think about pulse as well. So again, bringing in lots of nice musical vocab as well as thinking about computing. So again, we're starting to think about pulse and rhythm here. The children can have a really good play with this, a nice sort of tinkering session. But at the same time, if you don't have devices for every child to be on, or even in pairs, you could be doing the unplugged version of this. You could have some instruments out, some percussion perhaps, where in maybe 2s or 3s, they could be creating that little rhythm. And they are then tasked to try and think of a rhythm which will match an animal. And as we go through the unit, you'll see that that kind of builds up to the end of the unit, where they have to create a piece of music that will definitely match an animal's sort of signature. And for lesson 3, we start to think about Kandinsky, and I'm going to go into Kandinsky a bit later on as well. So here again, Holst, we're looking at listening to Neptune this time, and we want the children to be able to draw what they're feeling or draw what they can see in their mind's eye as they listen to this piece of music. And if you've ever seen the CBeebies program Melody, you'll know this type of an activity really well, because Melody is a little girl who has a visual impairment, but she'll listen to pieces of music. And as she's listening, she's kind of retells this story of how she's taking part, or how she's feeling as she listens to that music. So this time with Kandinsky, this is another part of Pro Music Lab. The children can draw if it's an iPad, they can just use their finger. If it's a PC or a laptop, they can use their mouse or their touch pad. And they're going to just draw anything that makes of whatever comes into their head as they're listening to Neptune. And when you've pressed the play button, you're going to be able to listen to what that drawing sounds like, which I think is amazing. At the same time as they're using this Kandinsky tool, they can start to look at how we can create different pictures of notes. So as we draw at the top part of the page, we're going to get a high note. As we draw something lower down the page, we're going to get a lower note. And again, if we keep that line nice and long, the duration of that note is going to be longer than if we're just using perhaps a dot or a short line. So again, the children are asked to try and think of an animal and match what they've created to the animal. Lesson 4, here we go with that music vocab again: pitch, pattern, notes, tempo, instruments. Now what we are moving on to now is this is Song Maker. This is another part of Crow Music Lab. The children can click on those little rectangle spaces and the colour depicts a new note. Again, as we go higher up the page, if I click in one of those rectangles, I'm going to get higher pitched sound, and so on. Now, as I have gone around and click, 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 click lots of those spaces, I can then press that nice big play button and listen to what it sounds like. If I want the children to experiment with different sounds and different instruments, I can change where that woodwind label is. I can then click on that. It'll change the instrument, and I can also change the percussion, which at the bottom of this screen you'll see is in dots rather than the rectangle blocks. So I can change the percussion instrument as well. And the tempo, so the speed of which it's being played, can also be changed with the drag option. The children can save their music, which is wonderful. It'll just save as a MIDI file or something similar. Now, the children, it depends what year group you're doing this with and whether or not they're okay with saving, but it's a basic skill. We do need to be teaching them this. So once they have downloaded it as a MIDI file, then perhaps that could be then saved into their pupil folder or whatever it is that you use to keep the evidence of their computing or music work. Now, as we move on to lesson 5, they're going to be choosing an animal again. So that will have kept in their mind. Now, let's say they were choosing, let's go for the kangaroo. So what type of sounds are we going to be creating to mimic the movement or the behavior of a kangaroo? It's probably going to be going up and down to match its movement as it bounces along. So the children are going to have to think about that and match it. They're going to have quite a bit of fun doing this, but the planning stage needs to be there. They need to be really thinking about their animal. They might want to do a bit of a sort of planning project based on their animal. So if you can, you try and make it as cross-curricular as possible. Maybe they're doing topics on animals or the Big Five or something similar. Now, lesson 6, they're editing. And that's great because they can go back to the file that they saved earlier, retrieve that file, another basic skill that we need them to practice. And really, what they're doing is they're looking at the pattern. Now, these notes, we could call it code because each image, each little shape, rectangle, triangle, circle, it is code for a sound. So all we're asking them to do as we edit, and let's bring it back to sort of more computing and programming type links here, we're going to ask them to debug what they have created with their digital music. So just try and bring that computational thinking into play as much as you can to make it not just music related, but also computing as well. And of course, if they have made a mistake, they can press the undo button. There are other tools. I've mentioned the Melody program from CBeebies already, so that's your third option down on this page. You've also got Isle of Tune. If you've got Chromebooks, there is an option to get Isle of Tune downloaded onto the Chromebooks as well, but it's not that link, it's another one. You've got a nice unit from iLearn2, which is a free unit from them, looking at music creation. And one that I quite like is the Kazoops Radio from the BBC. So there are lots of different ways to teach music with computing. I wanted to kind of just go quickly into the Kandinsky style element of teaching music with computing, again, because I wanted to look at synesthesia. So this is what Kandinsky lived his life with. It was where he could hear the colours and the shapes. And as he created artwork, we can see that that artwork will have sounded immense. It would have sounded perhaps even a bit orchestral. Now, this artwork by Kandinsky, red, yellow and blue, can actually be found if you go onto the arts and culture site with Google. You can have a look at this piece of artwork, and what Google have done is they've put the music that they believe, or what AI has sort of created, what we believe Kandinsky would have heard as he created this piece of artwork. So you can play these play buttons to hear what that part of the picture would sound like. Now, I think this is absolutely amazing, and for children who maybe they steer clear of writing, and I know many of my Key Stage 1 children would do, and Key Stage 2, if that's what they're steering clear of, this is an amazing way to be creative and get their feelings and their thoughts out, but just through art and sound and music in a digital way. So they're practicing those key skills for computing as well. So I don't know, Sarah, if you can get that link, the arts and culture one, into the chat, but if you can't, you can go to the Google Arts and Culture website and have a look. Sorry, Sarah, did you say you could?
Yeah, it's in. I'm on it with all your links. So.
Fab. That's great. And I might be able to come back to that in a second. The other tool or resource that I wanted to share with you was something that I'd found not too long ago, actually. This is from Midnight Music. It's an Australian site. It's a lady who loves music and digital music, and she's trying to find as many different ways to teach music, but digitally. So there's lots of tech links there as well. And on her site, I've just sort of brought some of her ideas and put them onto this slide. She's using this Kandinsky tool from Pro Music Lab, and the ideas have come through this lesson plan. So first of all, she'd allow the children just to tinker a little while, just to sort of allow that to happen and allow them to see what happens. So if you do draw a circle, it actually produces this smiley face, which is just gorgeous. But within the lesson plan, we've got little steps for the children to try. So try just drawing straight lines. Excuse me. So just drawing straight lines and then pressing play. So what do straight lines sound like? And can we draw some lines to create some different sounds and some different music? What happens if you actually just write your name or draw your name, whichever way you want to say it? What does your name sound like? I mean, that would be awesome if you could just actually hear what your name sounds like. And then sort of moving along, sort of similar lines as to what the NCCE unit was, composing your favourite creature. So perhaps draw the ladybird, or draw your elephant, or draw the cat, and then have a listen to see what your favourite animal, creature, mini beast, or even maybe it's not an animal, maybe it's just a plant, perhaps a living thing, and see what that sounds like. So the children are going to have a lot of time to be creative here. So that's from midnightmusic.com, and she's got some fab ideas for music and technology. So lots of cross-curricular links. So the other thing I was going to just very quickly show was the this is the Google Arts and Culture website. I don't think the sound's going to come through if I click on the circle like it's asking me to. But as I do click, the colour that is depicted on the screen will play different music. So the children are getting a really nice idea of how Kandinsky would have sort of viewed and lived the world. It's definitely something to have a go at. Now, as you go through that, this is kind of, well, it's just a nice introduction really for the children, because they will move on to looking at colour and shape. And if I just click on here, the painting, here's the red, yellow, blue that I was talking about just a moment ago. Again, I don't think you'll be able to hear it, but as I click on, it then plays. So I can hear what that part of the artwork sounds like. And then you get to have a go at trying it yourself. The other resource I mentioned was this one, which is the Midnight Music one. And this is what it looks like. So you can see here that it's just a blog, but they've put some really lovely ideas in about Crow Music Lab and what to do. And as I just scroll down here, you're going to be able to see there are extensions. So if you are thinking it's a bit Key Stage 1-y and you're wanting something for your Key Stage 2 children, there are definitely some, here we go, some links to some other areas to explore synesthesia. Okay, I think I'm going to stop there, Sarah. I don't know how much time we've got left.
No, I mean, I would love you to go on for ages, but we are we are limited on time. Thanks, Helen. That was amazing. I've written down some links myself that I haven't seen, because as always, you know, you've got loads of ideas. Thank you, both of you. Thanks, Sally and Helen. I don't really think we've got time for questions, because you had so much brilliant things to share. If you do have questions, if you want to pop into the CAS forum in the primary section and just put them in there, because I know Helen and Sally can pick up questions from there, or in the CAS primary Facebook group. That would be really helpful. But absolutely brilliant, really, really good. I love cross-curricular computing, but I love how inspirational you both are, so thank you. Okay, so at the end of this webinar, anyway, a short survey is going to appear on the screen. Would be really thankful if you could take a minute or so to fill that in. A recording of this webinar will be available on the CAS YouTube channel very soon. Finally, we hope to see you at some more of the CAS Virtual Showcase sessions. We've got 2 great sessions coming up tomorrow. One of our keynotes, actually another of our keynotes, looking at health and well-being for all in a blended learning environment. And at 5 p.m. we've got an Instagram live account looking at tech to support SEND. So I'll definitely be working out how I can get onto an Instagram live event. Looking forward to that. So get booking on our site if you haven't done so already. Please continue to spread the word about computing at school. And that's us done for today. Thanks for joining. Thanks for our guests, and have a lovely rest of the day. Bye for now.
Bye.
Bye. Thank you.
Bye.